Slope-intercept form, Lesson 3.4, Part A. The standards are 8EE6, 8F3, and 8F4. The objective is to graph linear equations using the slope and y-intercept. The essential question: why are graphs helpful? Slope-intercept form of an equation is written as y equals mx plus b, where m is the slope and b is the y-intercept. Now the y-intercept is where x equals 0 and the line crosses the y-axis. Now in a proportional graph, it's written as y equals mx. That's because the y-intercept is 0 and we don't write plus 0. To be proportional, 1, it must be a straight line, and 2, the line must pass through the origin. Example number 1. State the slope and the y-intercept of the equation. Y equals negative 5x plus 3. So remember, the slope is the coefficient of x, which is negative 5. And b, which is the y-intercept, is 3. Example number 2. State the slope and the y-intercept of the equation. Y equals 1 over 4x minus 6. Now remember, our slope is the coefficient of x, which is 1 over 4. And our y-intercept, which is represented by b, is negative 6. Example number 3. State the slope and the y-intercept of the equation. Y equals negative x plus 5. So remember, our slope is the coefficient of x. So I know it's going to be negative. However, when you don't see a number in front of the variable, that means there's an invisible 1. So my slope is negative 1. Now my y-intercept is going to be 5. Example number 4. Write an equation of a line in slope-intercept form with a slope of 3 over 4 and a y-intercept of negative 3. So my equation in slope-intercept form would be written as y equals mx plus b. So we would just have to replace our m, which is our slope, and our b, which is our y-intercept. So I would write y equals m is our slope, which is 3 over 4, x, and then our y-intercept is negative 3. So I would write negative 3. So my equation in slope-intercept form is written as y equals 3 over 4x minus 3. Example number 5. Write an equation of a line in slope-intercept form for the graph shown. So first, we're going to start with the y-intercept, which is represented as b. And I know that the y-intercept crosses on the y-axis, so it crosses right here. So that means my y-intercept is at negative 2. Now I'm going to pick another point on the graph. I'm going to pick the point here, and I'm going to draw a triangle. That way I can find my rise over my run. So my run is 1, 2, 3, and my rise is 1, 2, 3, 4, 5. So remember, my slope is my rise over my run, which is 5 over 3. So now I'm going to write my equation. Y equals, my slope is 5 over 3x, and then my y-intercept is negative 2. So my equation in slope-intercept form is y equals 5 over 3x minus 2. In real-world situations, slope is the rate of change. The y-intercept is the initial starting value. So in our equation, y equals negative 6x plus 90, our rate of change is our slope, which is negative 6. And our starting value is our y-intercept, which is 90. Example number 6. A taxi fare y can be determined by the equation y equals 0.50x plus 3.50, where x is the number of miles traveled. A. Interpret the y-intercept. So we know that the y-intercept is 3.50. So the y-intercept is when x equals 0. So that means that the taxi fare is going to start at $3.50. Now B, interpret the slope. So we know that the slope is 0.50. So that means it costs 50 cents per mile traveled. Example number 7. What is the y-intercept for each line drawn below? Now remember, the y-intercept crosses on the y-axis. So we're going to start with this one right here. So I notice that that one crosses at 1, 2, 3. So B represents the y-intercept. It crosses at 3. So now let's do the next one. This crosses at 0. So the y-intercept equals 0. And that would be a proportional relationship. Now this last one here crosses at 1, 2, 3, 4. So B is -4.